to impossible logic problems to fall asleep to. The infinite library. Picture an endless corridor stretching into eternity. Lining its walls are shelves that reach the heavens, stacked with books of every imaginable size, shape, and color. Each book holds a unique story, a sequence of letters, numbers, or symbols that has never been written before. Some contain entire novels, others are filled with nonsense. There are books in languages you recognize and countless others in scripts no human has ever seen. This is the infinite library, a place where the possibilities are boundless, yet where meaning feels tantalizingly out of reach. As you wander through the vast labyrinth of knowledge, you pick up a volume at random. Its cover feels ancient, but its pages are pristine. You read a line. It's perfectly coherent, a passage describing a serene garden you've never visited yet feels oddly familiar. You flip to another page, and suddenly the text becomes disjointed, filled with words that don't belong together. Is it nonsense, or is it a code waiting to be cracked? You realize this library isn't just a collection of stories, it's a map of all that could be. Every book represents a possible arrangement of letters, meaning that somewhere in these infinite shelves lies every truth, every lie, every idea ever conceived. The beauty and the terror of the infinite library lie in its completeness. Within it, you might find a book that tells the exact story of your life, down to the smallest detail. Next to it, there could be another volume where your life takes a completely different turn, one where you made every choice differently, and yet another that tells a story so surreal, it's as if it belongs to a dream. The library isn't limited by reality, it holds the entirety of what's imaginable. But then a troubling thought arises. If every possible arrangement of letters exists here, then most of these books must be gibberish. For every profound insight, there are countless volumes of randomness. You find a book that starts coherently, then descends into meaningless strings of letters. Another book repeats a single letter for thousands of pages. Another still is filled with diagrams and strange symbols that defy interpretation. The task of finding meaning in this sea of randomness feels insurmountable. This brings us to the paradox at the heart of the infinite library. If every possible story, every possible truth, is contained within these shelves, does that mean the library itself holds no meaning? Or does it mean that meaning is everywhere, waiting to be uncovered? If you knew that the exact answers to every mystery of the universe were in here somewhere, but you had no way of finding them, would that knowledge comfort you, or would it drive you mad? The infinite library challenges our understanding of knowledge and discovery. In our world, we value information because it's scarce. We treasure books, ideas, and insights because they're rare and take effort to find. But in a library where everything already exists, where the answers to every question are already written down, what becomes of the search for understanding? Does it still have value if the answers are all out there, but you can't distinguish them from the noise? As you wander the endless halls, you begin to see the infinite library not as a storehouse of wisdom, but as a metaphor for the human mind. Just as the library contains every possible book, our thoughts contain every possibility. In our own minds, we sift through countless random ideas, searching for those rare gems of insight. The infinite library, then, is a mirror of our own inner worlds, a reflection of how we create meaning out of chaos. In the end, the infinite library doesn't need to be solved. It doesn't need to be conquered. It exists as a challenge to our understanding, an invitation to think about what it means to seek knowledge, to find meaning, and to embrace the mystery of infinity. It's not the answers you find in the library that matter. It's the journey of exploring its infinite possibilities. The paradox of the timeless clock. Imagine a grand hall at the center of the universe. Its towering columns stretch beyond sight, and its floor, polished and flawless, reflects the dim light of floating lanterns that seem to exist outside of time. At the very heart of this room stands a massive clock, its face gleaming like a silver moon, its hands delicately wrought from unknown materials that catch the faintest flickers of light. But this is no ordinary clock. Its hands do not follow the predictable march of minutes, hours, and days. The hour hand drifts ever so slowly, then stops. The minute hand spirals unpredictably, leaping forward and backward, while the second hand spins one moment and stands still the next. It's not broken, far from it. Instead, it defies the very concept of time. This is the paradox of the timeless clock. When you stand before it, you feel a deep and unsettling pull, as though you've encountered a truth that exists outside the framework of reality as you know it. Its movements suggest a rhythm you almost recognize, something you feel you've heard in a dream, yet can never quite grasp. It's as if the clock measures something far more profound than time, a constant, a presence, a passage that exists without beginning, without end. The idea unsettles you, makes you question the very nature of existence. What if time isn't what we think it is? What if it doesn't flow forward, but rather folds upon itself, loops endlessly, or perhaps doesn't move at all? Consider the purpose of such a device. Why would a clock exist that doesn't tell time? The thought bends the mind. We are so bound by the belief that time marches forward in neat, orderly intervals, seconds into minutes, minutes into hours, that stepping outside of this framework feels like standing on the edge of a precipice. But this clock does not care for such boundaries. Its hands move in patterns that mean nothing and everything at once. It marks something that no calendar can capture, something that no sundial could ever hope to measure. Perhaps it counts not time, but existence itself, tracing the eternal presence that underpins every moment, even those that never come. As you stare, you begin to feel as though the clock knows something you don't. Its deliberate ticking, soft and resonant, fills the hall like the heartbeat of the cosmos. It doesn't demand answers. It only poses a question that has no resolution. What if time is not linear? What if past, present, and future are not separate? What if they are all one, woven together in an intricate tapestry that we can only perceive thread by thread? The timeless clock invites you to let go of the idea that time must have a shape, that it must make sense. It challenges you to embrace a more unsettling, yet more profound possibility, that time is an illusion we impose on the universe, and that without our minds to break it into parts, it simply is. This thought experiment isn't about reaching a conclusion. It's about experiencing the paradox itself. It's about confronting the limitations of our understanding, the boundaries of human perception. We measure our lives in minutes and hours, days and years, because that's how we make sense of the world. Yet, standing before the timeless clock, you see the cracks in this logic. You realize that those measurements are not truths, they are agreements. The clock stands apart from our agreements, turning its hands in ways that no schedule, no calendar, no plan can contain. The timeless clock, then, is not simply a metaphor or a thought experiment. It is a reflection of the human struggle to grasp what lies beyond our understanding. It whispers that we may never know the answers to life's deepest mysteries, and in that realization, there is a strange peace. If we can accept that not every question has a resolution, that not every puzzle can be solved, we might begin to see the beauty in the unsolvable. We might even begin to let go of our relentless need to measure, to define, to conquer time. So as you step back from the timeless clock, its paradox still swirling in your thoughts, consider this. Maybe the clock's true purpose is to remind us that existence is far greater than the minutes and hours we count. It's an invitation to step outside the relentless flow of time, to find stillness in the endless now, and to let the unsolvable question rest gently in your mind, just as the hands of the clock rest gently on its face, spinning patterns that never end. The unsolvable maze. Imagine stepping into a labyrinth that seems to stretch on forever. Its walls are smooth and featureless, their colors shifting subtly as you move. Paths branch off in every direction, twisting and turning until they vanish into shadow. The air is perfectly still, and the silence is almost deafening. As you wander further, you start to notice something strange. Every time you think you're making progress, every time you feel certain you're heading toward the center, the paths change. A corridor that once led straight ahead now loops back. A corner you've turned dozens of times disappears when you glance over your shoulder. The maze is alive, shifting and evolving with every step you take. This is no ordinary puzzle. The unsolvable maze defies the very concept of completion. It isn't just large, nor merely intricate. It is designed so that no matter how cleverly you plan, how carefully you trace your route, you cannot escape. As soon as you think you've discovered a pattern, it dissolves. As soon as you believe you're closing in on the solution, the maze changes its shape, leaving you right where you started, or perhaps somewhere you've never been before. As you walk, you begin to feel the weight of its impossibility. Every turn leads not to progress, but to more uncertainty. You start to wonder, if a maze has no exit, is it still a maze? What is its purpose, if not to be solved? Perhaps the maze was never meant to be conquered. Perhaps it was meant to teach you something else entirely. The longer you wander, the more you realize that the unsolvable maze is a reflection of your own mind. The shifting corridors mirror the ways your thoughts twist and turn, constantly reconfiguring themselves. Just as you think you've settled on an answer, a new question appears. The maze shows you that life's most complex challenges are not puzzles to be solved, but journeys to be experienced. It asks you to let go of the need for resolution, to release the urge to find the exit, and to simply explore. As the walls shift around you, you start to notice subtle changes. The colors become richer, the patterns more intricate. You begin to marvel at the complexity of it all. Instead of frustration, you feel a sense of wonder. This is not a maze you escape. It's a maze you inhabit. It's a reminder that some mysteries aren't meant to be solved. Some paths don't lead out. They lead deeper in. The unsolvable maze invites you to embrace the unknown. It whispers that there's no need to reach a final destination. The beauty lies in the journey itself, the twists, the turns, the moments of discovery and surprise. And as you continue wandering, you might just find that the maze, in all its shifting complexity, is not a trap at all, but a place of infinite possibility. The Bridge of Shadows. Picture a bridge suspended over a vast, silent void. It doesn't appear to be made of wood, stone, or steel. Instead, it seems to be crafted entirely from shadows. The dark material shifts subtly as you step onto it, feeling both solid and ethereal. Beneath your feet, the void stretches infinitely, a bottomless chasm of darkness. The only thing holding you above it is this mysterious bridge, an architectural impossibility that defies the logic of light and form. As you walk, you notice that the bridge changes with each step. Shadows ripple outward, forming intricate patterns that twist and weave into new shapes. At first, these patterns seem random, but the longer you observe, the more deliberate they appear. They begin to resemble symbols, strange, ancient runes you cannot decipher. Could they be a code, a message left by some unknown intelligence? Or are they simply the natural result of light and dark playing on this unusual structure? You continue along the bridge, each step filling you with a mixture of awe and unease. The shadows seem to stretch out before you, extending the bridge as you move. Behind you, the path you've taken fades into the void. It's as if the bridge exists only in the moment, only for you. You realize that turning back is not an option. The bridge does not allow for retreat. Its very nature is to move forward, one step at a time. As you walk, the void below seems to shift, revealing hints of something more. Faint glimmers of light appear far beneath the bridge, flickering in and out like distant stars. They're not reflections of your surroundings, but something deeper, something that feels alive. You wonder if the bridge is a threshold, a boundary between worlds, and these lights are glimpses of what lies beyond. The thought is both exhilarating and terrifying. What might happen if you reach the other side? But then you realize something troubling. The bridge has no visible end. No matter how far you walk, the horizon remains the same. The shadows continue to reshape themselves, the patterns growing more complex, more intricate. You begin to suspect that the bridge may never lead anywhere, that it might simply extend forever. This isn't a bridge meant to take you to a destination. It's a bridge meant to make you walk. It dawns on you that the bridge of shadows is not a physical structure at all, but a metaphor, a reflection of life's journey. Its shifting shadows represent the ever-changing challenges and uncertainties we face. The void below is the unknown, the fears and doubts that always lurk at the edges of our perception. And the bridge itself, it is the act of moving forward, of continuing despite not knowing what lies ahead. The bridge doesn't ask you to understand its patterns or decipher its symbols. It doesn't promise a clear destination or a resolution to the mystery. Instead, it invites you to keep walking, to trust that each step will reveal just enough of the path to take the next. The bridge of shadows teaches you that progress doesn't require certainty. It only requires movement. And so, you walk, not because you know where you're going, but because the act of walking is its own purpose. The shifting patterns of shadows beneath your feet become less intimidating, even beautiful. The void below loses its menace, becoming a quiet companion rather than a threat. You find peace in the uncertainty, in the knowledge that you don't need all the answers to move forward. In the end, the bridge of shadows is a paradox. It is both there and not there, both finite and infinite, both solid and intangible. It challenges the way you think about paths and destinations, and it offers a simple truth. Life's greatest mysteries are not meant to be solved, but experienced. The beauty lies not in reaching the end of the bridge, but in walking across it, step by step, and marveling at the shadows as they shift and dance beneath you. The impossible lottery. Imagine yourself standing in a crowd, clutching a lottery ticket with a number so random, so unique, that it feels as if the universe itself might have whispered it into your ear. The air is electric with anticipation. Everyone around you is filled with nervous energy, checking and rechecking their tickets as the numbers are announced one by one. You watch as each digit is drawn, feeling your heart pound as you edge closer to what could be the biggest win of your life. Then comes the final number, the one that should seal your fate. You hear it, and it matches your ticket perfectly. For one shining moment, you believe you've won. But before you can celebrate, something inexplicable happens. The winning number changes. It doesn't just change slightly, it transforms completely. What was once a match is now something entirely different. The crowd murmurs in confusion. Some claim they've won, others say they haven't, and still others aren't even sure what the original numbers were. The announcer appears equally puzzled, yet they insist the new number is correct, as though it was the only number ever called. Your ticket, which a moment ago seemed to guarantee untold riches, is now as ordinary as any other scrap of paper. Welcome to the impossible lottery, a scenario where winning is never truly certain. It's a lottery not just of luck, but of logic itself. A game where the rules shift the moment you think you understand them. In this lottery, the very concept of winning becomes elusive. What does it mean to win if the winning number can never be fixed? What does it mean to lose if the loss is equally undefined? You might think this is a problem of fraud, a trick played on the participants. But that's not the point. The impossible lottery is not about deception, it's about the nature of certainty and reality. If the numbers can change after they've been drawn, then what do they represent? If a winning number can transform into something else, can you ever truly win at all? This strange situation forces you to reconsider what you thought you understood about fairness, chance, and outcomes. In most lotteries, the rules are clear. One set of numbers is chosen, and whoever holds the matching ticket wins. The impossible lottery takes that certainty and flips it on its head. The rules are still there, but they are not stable. They move and shift like sand underfoot, making the very idea of winning a fleeting illusion. As you stand among the crowd, looking at your ticket and trying to make sense of what just happened, you start to see the impossible lottery as a reflection of larger truths. It's not just about numbers or tickets. It's about how we understand success, how we define outcomes, and how we cope when the ground shifts beneath us. In life, we often think of certain achievements as victories: getting a job, reaching a goal, winning a prize. But what happens when those definitions change? What happens when what we thought was a win turns into something else entirely? The impossible lottery challenges us to embrace uncertainty, to accept that some things can never be pinned down. It reminds us that life is full of shifting circumstances, and that what we consider a win today might look entirely different tomorrow. Rather than feeling discouraged by this realization, we can find a strange kind of freedom in it. If the winning number is never fixed, if the rules can always change, then perhaps the true victory lies not in holding the winning ticket, but in learning how to adapt, how to let go of rigid expectations, and how to find meaning, even in the midst of uncertainty. And so, the impossible lottery becomes not a game to win or lose, but a journey of understanding, a reminder that the world is not always what it seems, and that sometimes the greatest insight comes from accepting the impossible as part of life's ever-changing game. The two-door paradox: one always lies, one always tells the truth. You find yourself in a dimly lit hallway. Two massive doors stand before you, identical in every way. One leads to freedom, the other to certain doom. In front of each door stands a guard. One of them always lies, while the other always tells the truth. You've been told you may ask one question, just one, and then you must choose. The tension in the air is palpable. The stakes couldn't be higher, yet the rules of this paradox are deceptively simple. How can you figure out which door leads to safety? At first, it seems impossible. You know one guard will never tell you the truth, but you have no idea which one it is. You don't know their names, their habits, or their personalities. All you know is that one speaks only lies and the other only truth. The logical trap is set, and it feels inescapable. No matter which guard you ask, you risk being deceived. The wrong question could send you down the wrong path forever. But then, a spark of realization. The solution lies not in trying to determine who is truthful and who isn't, but in crafting a question that makes the distinction irrelevant. The classic answer is this: ask either guard what the other would say if you were to ask which door leads to safety. The liar will lie about what the truthful guard would say, and the truthful guard will truthfully tell you the liar's false response. In both cases, the answer points to the door that leads to doom, allowing you to choose the opposite one. Yet, even once you know the solution, the two-door paradox remains fascinating. Why? Because it's not just a test of logic, it's a meditation on the nature of truth and lies. In real life, we often face situations where we don't know whom to trust. People's words can be contradictory, their motives unclear. The paradox distills this uncertainty into a single, simple scenario. It challenges us to think beyond surface appearances and to consider the deeper patterns of communication and intention. There's something profoundly unsettling about being in a situation where you can't rely on what someone says. The liar could look you straight in the eye and tell you the exact opposite of the truth, while the truth teller could appear just as sincere. In this paradox, their demeanor doesn't matter. The solution depends on structuring your question so that the answer is unambiguous, regardless of who is answering. The two-door paradox also highlights the power of asking the right question. In life, the questions we ask often shape the answers we receive. A poorly phrased question can lead us down the wrong path, while a carefully considered one can reveal hidden truths. The paradox is a reminder that the way we approach a problem, our angle of inquiry, can make all the difference. Sometimes, it's not about having all the information, but about knowing how to use the limited information we do have. Ultimately, the two-door paradox isn't just about choosing the right door. It's a thought experiment that asks you to confront uncertainty head-on. It challenges you to think logically, creatively, and strategically. And in doing so, it teaches a valuable lesson. Even in the most perplexing situations, a well-crafted question can guide you to the truth. The ship of Theseus. When is the ship no longer the same? Imagine a grand, ancient ship resting in a harbor, its wooden planks weathered by time, its sails bearing the scars of countless voyages. The ship of Theseus is a vessel steeped in legend, a symbol of heroism and perseverance. Over the years, though, some of its boards begin to rot, and the crew replaces them, one at a time. The masts are swapped out, the rudder is repaired, and eventually even the sails are replaced with new ones. Decades pass, and by now, every single component of the ship has been exchanged. And here the question arises, is it still the same ship? This is the classic paradox of the ship of Theseus, a thought experiment that has puzzled philosophers for centuries. The ship appears identical in form, yet none of its original materials remain. If it's still the same ship, then what is it that makes it so? Is it its shape, its history, or simply the idea of the ship that persists through time? If it's no longer the same, then at what point did it change? When the first plank was replaced? When half the boards were swapped out? Or only once every single piece was new? As you ponder these questions, another twist emerges. Suppose that somewhere, the original planks of the ship of Theseus have been carefully stored and preserved. Over time, someone reassembles these old parts into a ship, identical to the original in every detail. Now there are two ships, one made of entirely new material that has never ceased to be called the ship of Theseus, and another composed of the original wood that once carried that name. Which is the true ship of Theseus, or are neither or both the real ship? This paradox challenges the very nature of identity and change. It asks you to consider what makes something what it is. Is it continuity of function, the essence of its design, or the material from which it is made? The question applies not only to ships, but to all things. Imagine a family heirloom that's been restored repeatedly over the years, or a city that has rebuilt itself countless times. Even our own bodies, constantly regenerating cells, shedding old material and forming new, are in a state of perpetual renewal. If our physical composition changes over time, are we still the same person we were years ago? Some argue that identity is not tied to any one material or component, but to a pattern or form that persists through change. The ship of Theseus remains the same, not because of its individual planks, but because it has continuously been recognized as that ship by those who maintain and sail it. Others suggest that identity is fluid, that the ship was never truly one thing, but rather a series of overlapping phases. Each replacement plank is a continuation, not a break, in the ship's story. This paradox also highlights how we, as humans, construct meaning. We create names, stories, and histories that bind objects and ideas together across time. The ship of Theseus becomes not just a collection of wooden boards, but a symbol of something larger, of endurance, memory, and legacy. Yet, these symbols are, in a sense, illusions we agree to believe. The ship is the same because we say it is, because we need it to be. Without that shared belief, the paradox would not exist. Ultimately, the ship of Theseus invites us to embrace the complexity of identity and the inevitability of change. It teaches us that continuity is not always a matter of material permanence, but of perspective and interpretation. In the end, the ship, like all things, is both the same and not the same. A reminder that life is a constant process of renewal and redefinition, and that what we hold on to most tightly may be the story we tell ourselves about what endures. The infinite chessboard. Is there a winning strategy? Imagine an endless expanse of black and white squares stretching out in all directions. There's no edge, no final row or column, just a chessboard that extends forever. On this infinite stage, the familiar pieces are set: pawns, knights, bishops, rooks, a queen, and a king. The rules of movement remain the same, but the game has changed. No longer constrained by the finite boundaries of a standard board, this infinite chessboard opens the door to a realm of uncharted possibilities and a puzzling question. Is there a strategy that can guarantee victory? At first glance, it might seem that extending the board to infinity shouldn't alter the fundamental rules of the game. After all, pieces still move in the same patterns, and the goal, checkmate, remains unchanged. Yet the infinite nature of the board adds a layer of complexity that defies traditional chess logic. On a standard 8-8 board, every move brings you closer to a conclusion, whether that's a win, a loss, or a draw. But on an infinite chessboard, the boundaries that typically guide a player's strategy no longer exist. Without a final row or column, without a corner to trap a king, how can you formulate a plan that reliably leads to victory? As you envision this boundless chessboard, a few scenarios emerge. Imagine a pawn advancing step by step. On a standard board, it eventually reaches the 8th rank, where it can be promoted. On an infinite board, however, that pawn may march forward endlessly, never reaching a stopping point. What becomes of its journey? Can it ever fulfill its purpose? Or is it doomed to wander the squares without achieving promotion? Similarly, a rook or bishop may sweep across the board, covering countless squares, yet never quite reaching a decisive position. The infinite expanse transforms these pieces from tactical tools into explorers, navigating a plane where checkmate may lie perpetually out of reach. Then there's the question of time. In a finite game, every move matters, every decision counts toward the end game. But in an infinite game, what does it mean to progress if the board has no boundary? Can there ever be an end game in the traditional sense? Or does the game stretch on forever? If a king is never cornered, if a pawn never promotes, is there ever truly a conclusion? Some mathematicians and logicians have pondered what a winning strategy might look like on an infinite chessboard. They explore questions of symmetry, of how pieces influence the board on a grand scale, and whether certain positions are inherently winning or losing. Yet these analyses often lead to more questions than answers. For every proposed strategy, there seems to be a counter-strategy, a counter-strategy, and so on. The infinite nature of the board means that the space of possible moves is not just large, it's unbounded. No matter how carefully you plan, there's always another square, another twist, another turn to consider. In this way, the infinite chessboard becomes more than just a setting for an unusual game. It's a metaphor for life's complexities, for the challenges that never truly resolve. In life, as on the infinite chessboard, we seek strategies to reach our goals. We plan, we adapt, we move our pieces. But there's always another challenge, another decision to make. The horizon keeps shifting, the board keeps expanding. And perhaps that's the beauty of it. The infinite chessboard isn't about winning or losing. It's about the endless dance of possibilities, the joy of exploration, and the knowledge that no matter how far you go, there's always more to discover. So, is there a winning strategy on the infinite chessboard? Perhaps the real answer lies not in checkmate, but in the journey. It's not about finding a final move. It's about marveling at the infinite expanse of moves before you. It's about embracing the paradox of striving for a goal that may never be reached and finding meaning in the play itself. In the end, the infinite chessboard isn't just a puzzle. It's an invitation to wonder, to dream, and to keep moving forward, one square at a time. The missing dollar puzzle. Where did the money go? Picture three friends on a road trip, stopping for the night at a small motel. They're on a tight budget, so they choose a room advertised for $30. Each friend contributes $10, and together they pay the total at the front desk. All seems simple enough, and the trio heads up to their room, ready to rest after a long day's drive. But behind the scenes, there's a small twist. The motel clerk realizes he made a mistake. The room actually costs only $25. He calls over the bellhop, hands him $5, and says, "Take this back to the guests as a refund." The bellhop, however, faces a dilemma. How do you split $5 evenly among three people? Rather than doing the math, he pockets $2 for himself and returns 3 to the friends, giving each one $1. Now, each friend has paid $9 and they're satisfied with the small refund. They still believe they got a fair deal, even if it wasn't the full $5. But then the question arises, if each friend paid $9 for a total of $27 and the bellhop kept $2, that adds up to $29. What happened to the missing dollar? This is the riddle that stumps so many. At first, it seems straightforward. 3 people pay $30, then receive some money back. Yet when you start adding and subtracting the amounts, the numbers don't align. That one missing dollar becomes a source of confusion, a tiny mystery that feels impossible to resolve. So, where did the dollar go? The key to solving this puzzle lies in examining the logic behind the numbers. The confusion arises from adding the $2 kept by the bellhop to the 27 that the guest paid after the refund. These figures don't belong together in the same equation. The $27 already accounts for the $25 room cost and the $2 kept by the bellhop. There's no missing dollar, just a misplaced calculation. The missing dollar puzzle isn't a matter of dollars vanishing. It's a lesson in careful reasoning. It highlights how easily our minds can be led astray when we try to combine numbers that don't truly correspond. It's a reminder to look beyond the surface of a problem and consider how the pieces actually fit together. In a sense, this riddle is more than a simple math trick. It reflects the way we often approach problems in life. Sometimes the answers aren't missing at all. We're simply looking at them the wrong way. The missing dollar isn't lost. It's hiding in plain sight, waiting for us to shift our perspective and see the situation clearly. And so, the next time you hear about the missing dollar puzzle, remember that the mystery isn't in the math. It's in the way we think, the assumptions we make, and the ease with which a simple question can lead us down a winding path. The dollar was never truly gone. It was there all along, hidden in the logic of the problem, just waiting to be understood. Zeno's paradoxes. Can you ever really reach the end? Imagine you're standing at the starting line of a race. The finish line is visible in the distance, a mere 100 meters away. As the race begins, you set out toward the finish line, moving at a steady pace. But before you can reach it, you must first cover half the distance, 50 meters. Once you've covered that half, you must then cover half of the remaining distance, 25 meters. Then half of the next remaining distance, 12.5 meters, and so on. Each step requiring you to cover half of what's left. Zeno's paradox arises from this scenario. It argues that before you can reach the finish line, you must first complete an infinite number of smaller and smaller steps. Since it takes some amount of time, however small, to complete each step, Zeno concludes that it's impossible to ever truly finish the race. How can you reach the end if there's always another fraction of the distance to go? At first, this might sound absurd. After all, in the real world, we clearly finish races and reach our destinations. But Zeno's paradox isn't about the physical act of walking or running. It's about the logic underlying motion itself. By dividing the distance into infinitely smaller segments, Zeno highlights a seeming contradiction in our understanding of continuous movement. If you must traverse an infinite number of points, how do you ever reach the final one? This puzzle has intrigued thinkers for centuries, not because it suggests people can't actually move, but because it forces us to confront the nature of infinity. The paradox shows that our intuition often struggles to grasp the concept of an infinite process. Intuitively, we expect that if something is made up of infinite parts, it would take infinite time. But the resolution of Zeno's paradox lies in understanding that an infinite series of steps can sum to a finite amount of time. Mathematically, we know that the series 1/2 plus 1/4 plus 1/8 plus 1/16 converges to a limit. In this case, the total distance of 100 meters. While the number of steps is infinite, their combined length is finite, allowing you to reach the end. Zeno's paradox isn't just a math problem. It's a challenge to how we perceive motion, time, and change. It asks us to think about how we measure progress, how we break down continuous processes into discrete parts, and how our understanding of infinity shapes our view of the world. The paradox invites us to ponder not just whether we can reach the finish line, but what it even means to arrive. In this sense, Zeno's paradox is both a philosophical and a mathematical riddle. It reminds us that the world isn't always as straightforward as it seems. Sometimes, the journey to understanding requires taking an infinite number of logical steps, each one bringing us closer to a clearer view of the truth, even if that truth remains just out of reach. The unexpected hanging paradox. Can you predict the unpredictable? Imagine a judge issuing a peculiar sentence to a prisoner. You will be hanged at noon on one weekday next week, but you won't know which day it will happen until the executioner arrives. The prisoner is perplexed. How can such a thing be? The judge's words seem clear, but the conditions leave the prisoner struggling to figure out when this punishment might occur. The prisoner begins to reason it out. First, he thinks, it can't happen on Friday. If I reach Thursday at noon and the hanging hasn't occurred, I'll know it must be Friday. But the judge said I wouldn't know in advance, so Friday is ruled out. Then he considers Thursday. If Friday is out and I get to Wednesday noon without the hanging, it must happen on Thursday. But again, I'd know it's coming, so Thursday can't be the day either. He continues this logic backward, day by day, until he concludes that the hanging can't happen on any day of the week. Confident that the judge's statement is flawed, the prisoner goes to sleep without worry. But then, on Wednesday at noon, the executioner arrives unexpectedly. The hanging occurs, and the prisoner is caught completely off guard, just as the judge predicted. The paradox is that the hanging happens exactly as described. It's both unexpected and unpredictable, depending on how you interpret the conditions. The unexpected hanging paradox reveals a deep tension between logic and surprise. The prisoner's reasoning appears sound at first. By ruling out each day based on the requirement of not knowing, he builds a case that the event can't occur at all. Yet the very structure of the judge's statement ensures that the prisoner's certainty will be his undoing. The moment he believes he has outsmarted the paradox, he becomes vulnerable to it. This paradox challenges our understanding of knowledge and expectation. How can something be logically ruled out and yet still happen? It highlights the limitations of reasoning when confronted with self-referential statements and conditions that shift depending on perspective. The prisoner's analysis is correct up to a point, but the paradox doesn't play by ordinary rules. It thrives on the gap between what can be logically deduced and what can actually occur. At its heart, the unexpected hanging paradox is more than a simple riddle. It's a reflection on the nature of certainty and surprise. In life, we often try to anticipate events, to plan for the future, and to reason our way into a sense of control. But sometimes, as this paradox shows, the very act of predicting can lead to outcomes that feel unexpected, even inevitable. It's a reminder that logic has limits, and that not everything can be neatly resolved by reasoning alone. The unexpected hanging paradox leaves us with an unsettling question. Can we ever truly prepare for the unknown? Or does our effort to predict the future sometimes blind us to the very surprises that make life unpredictable and, perhaps, more interesting? The liar's paradox. Is the statement itself true or false? Imagine someone looking you straight in the eye and saying, "This statement is false." You pause, thinking it over. If the statement is true, then it must be false, as the speaker claims. But if it's false, that would mean it's actually true. And there you find yourself, caught in a loop of contradiction that refuses to resolve. This is the liar's paradox, a puzzle that has captivated philosophers, logicians, and thinkers for millennia. The paradox may sound deceptively simple, but its implications run deep. It's not just about the truth or falsity of one statement. It's about the very foundations of language, logic, and meaning. If a single sentence can simultaneously declare itself true and false, what does that say about our systems of reasoning? How can we trust language, our primary tool for conveying ideas, if it can so easily turn back on itself? In trying to untangle the paradox, you might consider what makes a statement true or false in the first place. Truth, in most contexts, is about correspondence. What we say matches what is. If I say, "The sky is blue," and you look up to see a clear, sunny sky, the statement is true. If it's cloudy or dark, it's false. But the liar's paradox breaks this simple rule. Its truth or falsehood doesn't depend on external reality. Instead, it refers only to itself. And when a statement loops back on itself in this way, the usual rules of truth collapse. Some have tried to resolve the paradox by rejecting it outright, claiming that self-referential statements like "this statement is false" aren't real statements at all. They argue that for something to be a meaningful statement, it must be grounded in an external reality. Without that grounding, the paradox is nothing more than a linguistic trick, a glitch in how we use words. Others have attempted to develop entirely new logical systems that can handle such self-referential loops, hoping to create a framework where the liar's paradox becomes not a contradiction, but a special case of meaning. Yet, even with these efforts, the liar's paradox remains a symbol of how complex and slippery truth can be. It reminds us that not all questions have neat, tidy answers. Some problems resist resolution not because they're poorly constructed, but because they reveal the boundaries of our understanding. The paradox isn't just a nuisance, it's a profound statement about the nature of language and thought. The beauty of the liar's paradox is that it continues to challenge us, generation after generation. It sparks debates, inspires new theories, and pushes the limits of logic itself. It's a reminder that even in the realm of abstract reasoning, there are mysteries that defy easy solutions. And in that sense, it's not just a puzzle. It's a doorway into deeper questions about how we know what we know, and whether some truths can ever truly be pinned down. Schrödinger's cat, the puzzle of quantum uncertainty. Picture a sealed box sitting on a table, its contents hidden from view. Inside, there's a cat, a vial of poison, and a radioactive atom. The setup is as follows. If the atom decays, it triggers the release of the poison, and the cat dies. If the atom does not decay, the cat remains alive. The twist is that, until you open the box to observe what's happened, the cat exists in a state of quantum uncertainty, both alive and dead at the same time. This is the famous thought experiment known as Schrödinger's cat, a paradox that sits at the heart of quantum mechanics. At first glance, it seems absurd. How can something be alive and dead simultaneously? In the everyday world we experience, an object or creature is either one thing or another. A cat is either curled up and purring, or lifeless and still. There's no in between. But Schrödinger's cat isn't about the everyday world. It's about the strange, counterintuitive behavior of particles at the quantum level. In this realm, particles don't have definite states until they're observed. Instead, they exist as probabilities, a superposition of all possible outcomes. This thought experiment was not intended to suggest that cats, or any objects on our familiar scale, truly exist in two states at once. Schrödinger designed it to illustrate the bizarre implications of quantum theory. He wanted to show how the quantum rules, which work well for subatomic particles, produce nonsensical results when applied to larger, more tangible systems. The paradox highlights the disconnect between the quantum world and the macroscopic world we see and touch every day. Schrödinger's cat also raises questions about the role of observation and measurement. In classical physics, objects have definite properties regardless of whether anyone is looking at them. A rock on the ground has weight, shape, and color, even if no one is there to see it. Quantum mechanics, however, suggests that certain properties, like a particle's position or momentum, don't exist in a definite form until they're measured. The act of observation collapses the wave function, resolving the superposition into one outcome or the other. This notion challenges our intuitive understanding of reality. If the very act of looking at something changes its state, then what does that say about the nature of existence? Is the world we experience just one version of many possibilities, selected the moment we pay attention? Or does reality exist independently, waiting for us to uncover it? While the cat in the box scenario is an abstraction, it points to real phenomena that physicists study. The idea of superposition underlies technologies like quantum computing, where particles in multiple states simultaneously enable calculations far beyond the capabilities of classical computers. And though the thought experiment is often misunderstood as an argument about the literal state of a cat, it continues to provoke deeper inquiries into the nature of knowledge, observation, and the boundary between the microscopic and macroscopic realms. Ultimately, Schrödinger's cat is not just a paradox, but a doorway into the mysteries of quantum mechanics. It reminds us that our intuition, shaped by the everyday world, often fails when confronted with the strange and subtle truths of the quantum domain. By considering this paradox, we're invited to rethink what we know about reality and to accept that some aspects of existence may forever remain in the realm of probabilities and possibilities. Russell's paradox. Can a set contain itself? Imagine you are tasked with creating a collection or set of all sets that do not contain themselves. At first, it seems like a straightforward idea. Some sets, like the set of all chairs, do not include themselves as members, since the set isn't a chair. These sets would belong in your collection. Other sets, like the set of all things that are not chairs, do contain themselves, since the set itself is not a chair and thus meets its own condition. These sets would not belong in your collection. So far, so good. But then a problem arises. What about the set you are constructing? If it does not contain itself, then by its own rule, it must be included. If it does contain itself, then it cannot be included, because it only holds sets that do not contain themselves. This contradiction is Russell's paradox, named after the mathematician and philosopher Bertrand Russell, who uncovered it in 1901. It's a fundamental puzzle about the nature of sets, membership, and self-reference, one that shook the foundations of mathematics and logic. The paradox strikes at the heart of naive set theory, which assumed that any coherent condition could define a set. If you could describe a property, you could gather all the objects with that property into a set. But Russell's paradox shows that this approach leads to contradictions. It demonstrates that some conditions, like the rule defining the set of all sets that do not contain themselves, are too problematic to form legitimate sets. In other words, not every idea you can articulate results in a well-defined collection. This realization had profound consequences. It forced mathematicians and logicians to rethink the very foundations of their field. If sets could not be defined so freely, what rules were needed to avoid paradoxes? Out of this challenge emerged more rigorous frameworks for set theory, such as Zermelo-Fraenkel set theory, which introduced axioms to carefully limit the kinds of sets that can exist. These systems aim to prevent self-referential definitions and ensure that sets cannot be constructed in ways that lead to contradictions like Russell's. Beyond its technical impact, Russell's paradox also raises deep philosophical questions about self-reference and logic. At its core, the paradox reveals how something seemingly simple, deciding whether a set contains itself, can unravel our assumptions about consistency and truth. It forces us to confront the limits of our reasoning and the ways in which language and logic interact. If we can describe a set but not safely include it in our system, what does that say about the nature of description and definition? Russell's paradox is not just a mathematical curiosity. It's a reminder that the foundations of even our most trusted frameworks are not immune to scrutiny. It teaches us to be cautious about assumptions and to recognize that our most basic concepts, like collection or membership, may hold surprises we never anticipated. In that sense, Russell's paradox is both a challenge and an invitation. A challenge to refine our understanding of logic and structure, and an invitation to explore the delicate boundary between what can be conceived and what can be consistently defined. The barber paradox. Who shaves the barber? Imagine a small village with a curious rule. The barber shaves everyone who does not shave themselves. If you're a villager who doesn't handle your own shaving, the barber will do it for you. If you shave yourself, the barber leaves you alone. At first, this seems simple enough. But then someone asks a troubling question. Who shaves the barber? If the barber shaves himself, he falls into the category of those who shave themselves, which means by the rule, he should not be shaving himself. If he doesn't shave himself, then he falls into the group of people who do not shave themselves, and by the rule, the barber must shave him. Either way, the barber is trapped in a logical loop. This is the barber paradox, a thought experiment designed to highlight a fundamental problem with certain kinds of self-referential definitions. On the surface, the paradox appears to be about a person, a barber, and his grooming habits. But at its core, it's not about shaving at all. It's about the logic underlying the rules we construct. The barber paradox forces us to consider what happens when we try to define something in terms of itself. Just as Russell's paradox shows the contradiction in defining sets that refer to themselves, the barber paradox reveals the impossibility of creating a consistent rule that applies universally to everyone, including the rule maker. This seemingly trivial scenario teaches a profound lesson about the limitations of logic and language. When we attempt to define a group, those who do not shave themselves, and then apply that rule to the very individual who enforces it, the barber, we find that our neat, logical framework collapses. The paradox demonstrates that self-referential definitions can lead to contradictions, undermining the consistency we depend on for clear reasoning. The barber paradox has implications far beyond the shaving habits of an imaginary village. It's a reminder that our logical systems, no matter how carefully constructed, can run into trouble when they allow self-reference without restriction. It challenges us to examine the assumptions underlying our rules, definitions, and categories. By exploring the paradox, we learn to be cautious in how we define concepts and apply them, recognizing that not every rule can account for every scenario without contradiction. Ultimately, the barber paradox is a mirror held up to our reasoning. It shows us that even the simplest, most intuitive seeming rules can lead to puzzles that defy resolution. And it encourages us to approach logic and problem solving with a sense of humility, aware that our efforts to order the world are often limited by the very frameworks we create. The Hilbert Hotel. How do you fill infinity with more guests? Picture an extravagant hotel with an infinite number of rooms, each one occupied. Despite its apparent fullness, the manager assures you that they can still accommodate more guests. You wonder how this could be possible. If every room is already taken, how can anyone else check in? This is the mind-bending premise of the Hilbert Hotel, a thought experiment created by mathematician David Hilbert to explore the paradoxical nature of infinity. At first glance, the idea seems absurd. In a finite hotel, if all the rooms are occupied, there's simply no space left. But the Hilbert Hotel, with its infinite number of rooms, operates by a different set of rules. Imagine a new guest arrives. To make space, the manager asks every current occupant to move one room down. The person in room 1 goes to room 2. The person in room 2 goes to room 3, and so on. This shuffling continues indefinitely, freeing up room 1 for the new guest. Even though the hotel was full to begin with, the infinite nature of the rooms allows it to accommodate yet another occupant. The real surprise comes when more than one new guest arrives. Suppose an infinite bus pulls up, with an infinite number of passengers. The manager doesn't flinch. This time, the shuffling is more complex. Every guest currently in room N moves to room 2N. The person in room 1 moves to room 2. The person in room 2 moves to room 4, and so forth. This frees up all the odd-numbered rooms, an infinite set, for the passengers from the bus. Once again, the infinite nature of the hotel shows its flexibility. But the most astonishing scenario occurs when another infinitely large group arrives after that. Perhaps it's another bus, or several infinite buses, or even an infinite number of infinite buses. Each time, the hotel staff rearranges the guests, creating room for the new arrivals. It may sound impossible, but mathematically, the structure of infinity allows for this kind of rearrangement. Infinity isn't like a large number. It's a concept that defies our usual understanding of space and quantity. The Hilbert Hotel isn't just a whimsical story. It serves as a powerful illustration of how infinite sets behave in mathematics. It reveals that infinity is not a static thing, but a dynamic concept that can be manipulated in ways that finite quantities cannot. The experiment challenges our intuitions, showing that what seems logically absurd, like adding more guests to a full hotel, is perfectly reasonable within the framework of infinite mathematics. This thought experiment also invites deeper questions. If infinity behaves so differently from the finite world, what does that mean for our understanding of reality? How do we reconcile the concept of infinity with our everyday experiences? The Hilbert Hotel reminds us that infinity is not bound by our ordinary rules of addition and subtraction. Instead, it exists in a realm where even the full can always expand, and what seems impossible is, in fact, a fundamental property of the infinite. By exploring the Hilbert Hotel, we gain a glimpse into the strange and beautiful world of infinity. We see how mathematical reasoning can stretch beyond the boundaries of common sense, revealing truths that challenge our perceptions. The Hilbert Hotel may be a paradox, but it's also a doorway into the mysteries of the infinite, a place where our understanding of enough and too much ceases to apply, and where the impossible becomes possible. The riddle of the Sphinx. What walks on 4, 2, and 3 legs? Imagine yourself standing before a towering creature, a sphinx with the body of a lion and the face of a human. Its gaze is piercing, its presence both majestic and unnerving. It speaks a single riddle. What walks on 4 legs in the morning, 2 legs at noon, and 3 legs in the evening? The riddle feels ancient, like a secret passed down through the ages, and you sense that the answer carries more than just a solution. It holds a reflection of life itself. As you ponder the question, you begin to see its layers. At first, it seems to be a simple observation about different stages of life. Morning, represents childhood, when a person crawls on all fours. Noon is adulthood, the prime of life, when a person walks upright on two legs. Evening is old age, when a cane, the third leg, is often needed for support. The riddle describes the arc of a human life, from infancy to maturity to elderhood. But the Sphinx's riddle is not just a riddle. It's a mirror that forces you to confront your own journey through time. It's a reminder that we are all in a constant state of change. We start helpless, gain strength and independence, and eventually reach a point where we must rely on others once more. The riddle encapsulates the human experience, showing that life's progression is as natural and inevitable as the rising and setting of the sun. This ancient puzzle also invites deeper philosophical reflection. What does it mean to grow, to age, to change? The answer to the riddle, man or humanity, reveals not only the physical transformation we undergo, but also the wisdom and perspective we gain along the way. Each leg represents a phase of understanding, a way of interacting with the world that shifts as we move through life's stages. In another sense, the riddle of the Sphinx challenges you to think about time itself. Morning, noon, and evening are not just times of day, but metaphors for the phases of existence. By framing life as a single day, the riddle compresses our journey into a cycle that repeats endlessly. It reminds you that each stage is temporary, that what feels permanent now will eventually give way to something new. The Sphinx's riddle is more than a test of cleverness. It's a timeless meditation on the human condition. It forces you to step back and consider your place in the cycle of life, to appreciate the fleeting nature of each phase, and to embrace the wisdom that comes with each change. The Sphinx isn't just a guardian of secrets. It's a guide, prompting you to reflect on the passage of time and the shared experience of being human. In solving the riddle, you gain more than an answer. You gain a glimpse of the universal story that connects us all, a story of growth, transformation, and the inexorable march of time. The Sphinx's riddle endures not because it's difficult, but because it resonates. It reminds us that we are all part of the same cycle, walking first on four legs, then two, then three, and ultimately leaving behind a legacy of understanding. The logical hat puzzle. Can you guess your hat's color? You find yourself seated in a line with a group of people. Each of you is wearing a hat, either black or white, but you cannot see the color of your own hat. You can, however, see the hats of everyone in front of you. The person at the very back of the line can see all the hats in front of them. The next person sees all but one, and so on, until the person at the front of the line sees no one's hat, but knows everyone behind them can see theirs. No communication is allowed. The challenge: each person must guess their own hat's color, and only those who guess correctly will be freed. If a single mistake is made, no one goes free. The setup sounds almost impossible. How can you determine the color of your own hat when you have no information about it directly? How can a group, forbidden to speak or share information, collectively solve a puzzle where any wrong guess means failure? The solution lies in the power of logic and a clever strategy. Before the game begins, the group agrees on a system, typically using parity. For example, the person in the back of the line who can see everyone else's hats might declare white if they see an odd number of white hats in front of them, or black if they see an even number. This first declaration establishes a known pattern for everyone else. The second person can then count the hats they see, compare it to the pattern established by the first person, and deduce their own hat's color. Each subsequent person does the same, using the prior guesses and what they can see to logically infer their own hat's color. This systematic approach allows the group to break through what seems like an insurmountable challenge. Even though each individual has limited information, the combined use of logic and a pre-agreed strategy enables them to determine their hat's color with complete accuracy. The puzzle demonstrates how structure, planning, and logical deduction can overcome the most daunting restrictions. The logical hat puzzle isn't just an exercise in reasoning, it's a metaphor for collective problem solving. It shows how a group, when united by a shared understanding and strategy, can achieve what seems impossible. By aligning their actions and thinking steps ahead, they turn an individual guessing game into a coordinated, error-free process. In life, as in the puzzle, we often face situations where the information we need is not directly accessible. The logical hat puzzle reminds us that we can often find solutions by stepping back, crafting a strategy, and trusting in the power of logical reasoning and teamwork. It's not just a challenge. It's an elegant demonstration of how logic and cooperation can unlock even the most puzzling scenarios. The two envelopes paradox. Should you switch? You're handed two envelopes, each containing a sum of money. One envelope contains twice as much as the other, but you don't know which is which. You pick one envelope, let's say envelope A, and peek inside. It holds $100. Now, the question arises, should you keep envelope A or switch to envelope B? Your first thought might be to reason it out mathematically. If envelope A holds $100, then envelope B must contain either $50 or $200. On average, switching seems to yield more money because $200 is a greater leap above $100 than 50 is below it. But then a troubling thought emerges. The same logic applies no matter which envelope you choose first. You could apply this reasoning infinitely, always convincing yourself that the other envelope might be a better choice, and so you hesitate, caught in the paradox. The two envelopes paradox exposes a flaw in our intuitive approach to probability and expectation. It's not just a question of whether to switch, it's about the assumptions we make when we calculate potential outcomes. The paradox often arises from the improper use of averages, or from neglecting the initial probabilities. If you assume equal chances for each scenario, the expected value of switching always seems greater. Yet, this reasoning leads to a logical loop. If switching is always better, then the first choice doesn't matter. And if the first choice doesn't matter, why switch? This paradox highlights how easily our reasoning can be led astray by misapplying probabilistic thinking. It serves as a reminder that the way we frame problems and define probabilities is crucial. In this case, the paradox doesn't have a simple resolution. It's not a trick with a clever right answer. Instead, it challenges you to reconsider how you think about risk, reward, and uncertainty. The two envelopes paradox also invites you to think about decision-making under conditions of incomplete information. In real life, we often face choices where the potential gains and losses are unclear. The paradox mirrors these situations, forcing you to confront the fact that sometimes there isn't a perfectly rational answer, only a judgment call based on the best information available at the time. Ultimately, the paradox isn't about envelopes or sums of money. It's a thought experiment that encourages deeper reflection on how we approach uncertainty, how we weigh options, and how we accept that some choices will always carry a degree of mystery. In the end, the question isn't just whether to switch envelopes, it's how we navigate the broader paradoxes of decision-making in a world full of unknowns. The lottery ticket dilemma. Is it rational to hope? Imagine you've just purchased a lottery ticket. The jackpot is astronomical, enough to change your life forever. Yet, you know the odds are overwhelmingly against you. Statistically, you're more likely to be struck by lightning or attacked by a shark than to win. And yet, holding that ticket in your hand, you can't help but feel a glimmer of hope. You start to dream about what you would do with the winnings. But here's the question. Is it rational to hope? This is the lottery ticket dilemma. It's not about whether buying a ticket is a wise financial decision. That's a separate discussion. The dilemma lies in the emotional and philosophical tension between the minuscule probability of winning and the very human desire to believe in that tiny chance. On one hand, logic tells you that hope is futile. With such astronomical odds, it's essentially guaranteed that you'll lose. On the other hand, hope has its own value. It's a brief escape, a spark of optimism, a chance to imagine a different future. The lottery ticket dilemma is more than just a thought experiment. It's a reflection of how we navigate unlikely outcomes in life. We face long odds in many areas, pursuing a dream career, overcoming a seemingly insurmountable challenge, or even just hoping for good luck when everything seems to be going wrong. In these moments, is it rational to hope, or does hope become a kind of self-deception? Philosophers and psychologists have debated the nature of hope for centuries. Some argue that hope, even in the face of near certain failure, is an essential part of the human experience. It motivates us to take action, to keep striving, and to find meaning in the pursuit. Others caution that clinging to false hope can prevent us from accepting reality and making more grounded, practical decisions. The lottery ticket dilemma also highlights the complex relationship between probability and emotion. When we think about odds on paper, we tend to be cold and analytical. But when we're personally invested, when we imagine ourselves winning, we shift into a different mindset. The dream of victory, however remote, becomes a source of excitement and joy. In that sense, hope may not be rational in a strict mathematical sense, but it can still serve a psychological purpose. It lifts our spirits, fuels our imagination, and reminds us that even the unlikeliest of outcomes is still not impossible. Ultimately, the lottery ticket dilemma doesn't have a simple answer. It's not about proving hope right or wrong. Instead, it invites us to reflect on what hope means to us, why we cling to it even when the odds are against us, and how we balance the rationale and the emotional as we navigate life's uncertainties. Hope, it seems, is not something we calculate. It's something we feel, an acknowledgement that, no matter how slim the chance, the possibility of something extraordinary can be enough to keep us dreaming. The grandfather paradox. Can you prevent your own existence? Imagine a journey through time. You step into a machine that can carry you back decades to a point long before you were born. You're curious, adventurous, eager to see history unfold firsthand. But then a strange and unsettling question arises. What if, in the past, you encounter your grandfather before he had children, before he even met your grandmother? And what if, in some accident of fate, you prevent their meeting, or, more drastically, cause harm that ensures your grandfather never has children? The paradox is chilling. If your grandfather never had children, then your parent wouldn't exist, and by extension, neither would you. But if you never exist, how could you have traveled back in time to alter the past in the first place? This is the grandfather paradox, one of the most famous thought experiments in time travel. It reveals a fundamental contradiction. If you can change the past in a way that prevents your own existence, then you could never have made the journey to change it in the first place. The paradox places two versions of reality in conflict, one where you exist and one where you don't, and both cannot logically coexist. At its heart, the grandfather paradox challenges our very understanding of cause and effect. In everyday life, causes lead to effects in a linear sequence. If you drop a cup, it shatters. If you light a candle, it burns. But time travel, as depicted in this paradox, disrupts that sequence. It allows effects to ripple backward, changing the causes themselves. This creates a feedback loop that logic struggles to resolve. The paradox asks, if the past can be altered, what happens to the future that flows from it? This thought experiment has inspired countless debates among physicists, philosophers, and science fiction writers. Some propose that time travel might be impossible precisely because of such paradoxes. Others suggest that if time travel were possible, the universe would somehow prevent these contradictions. Perhaps you would be physically unable to interact with events that would erase your own existence, or maybe the timeline would correct itself, ensuring that your actions always lead to the same outcome. These ideas hint at a universe with built-in safeguards, where the rules of cause and effect cannot be broken, no matter how far back you go. Alternatively, some theorists propose the idea of multiple timelines or parallel universes. In this view, if you travel back in time and alter the past, you simply create a new branch of reality. Your original timeline remains intact, while the new timeline reflects the changes you made. In the case of the grandfather paradox, this might mean that your grandfather in the original timeline still has children, while the version of your grandfather in the altered timeline does not. You would exist in one timeline, but not in the other. This approach bypasses the paradox by allowing both outcomes to occur, each in its own separate universe. Beyond the mechanics of time travel, the grandfather paradox also invites us to think about identity and existence. If you were never born, what would it mean for the memories, decisions, and actions that define you? Does your identity depend on a single, unbroken chain of events, or could it be scattered across multiple timelines? The paradox forces us to confront the fragility of our existence, how our lives are intertwined with countless events that happened long before we arrived. Even without a time machine, the grandfather paradox serves as a reminder that our place in the universe is shaped by a vast, intricate web of causes and effects. In the end, the grandfather paradox isn't just a puzzle about time travel. It's a meditation on the nature of reality. It challenges us to consider how the past, present, and future are connected, and whether we can ever truly escape the bounds of causality, whether time travel remains in the realm of fiction or one day becomes reality. The grandfather paradox will continue to provoke our curiosity and expand our understanding of how time shapes the world and us. The paradox of omniscience. Can all-knowing truly exist? Picture a being that knows everything, past, present, and future. Nothing is hidden, nothing uncertain. This entity understands every secret, foresees every event, and grasps the deepest truths about the universe. It's the very definition of omniscience, unlimited knowledge. Yet, the idea raises a profound paradox. If such a being knows everything in advance, can it ever learn? Can it experience surprise, make decisions, or choose freely? Is omniscience truly possible, or does the concept unravel upon closer inspection? The paradox of omniscience hinges on the tension between knowing everything and the dynamic nature of existence. To be omniscient is to possess all knowledge, but if all is already known, then the process of discovery, of gaining knowledge, is excluded. This raises a puzzling question. If something can never learn or discover, can it truly know in the fullest sense? The paradox suggests that the very act of knowing everything may come at the cost of experiencing life as a series of unfolding events. One way to approach the paradox is to consider how time and knowledge interact. In our everyday lives, Knowledge is gained as events unfold. We learn from the past, observe the present, and anticipate the future, but we never know everything all at once. An omniscient being, by contrast, would see all of time laid out before it, a fixed tapestry rather than a flowing river. But if every event is already known, does that mean events are predetermined? Does omniscience imply that free will, choice, and uncertainty are illusions? Philosophers and theologians have wrestled with these questions for centuries. Some argue that omniscience doesn't necessarily negate free will, suggesting that knowing what will happen doesn't cause it to happen. Others contend that omniscience leads to a deterministic universe where every action is preordained and nothing truly changes. In either case, the paradox remains. Can a being that knows all truths also experience the richness of discovery, uncertainty, and change? Another layer of the paradox involves self-knowledge. If an omniscient being knows everything, does it also know itself fully? If it does, can it choose to change, grow, or evolve? If it cannot, then its omniscience might be limited in a sense, unable to include the experience of transformation. But if it can change, then that change itself would have to be something it always knew would happen, raising questions about whether the change is genuine. This thought experiment highlights the limits of our understanding of knowledge and existence. It shows that concepts we take for granted, like knowing, choosing, and experiencing, become profoundly complex when applied to something infinite or absolute. The paradox of omniscience challenges us to think more deeply about what it means to know, and whether knowledge is ever truly complete. In the end, the paradox may not have a definitive resolution. It's not about proving or disproving omniscience, but about exploring the implications of what it would mean. The paradox invites us to reflect on the nature of knowledge, the role of uncertainty, and the possibility that some truths may be beyond even the most all-encompassing mind. Whether or not omniscience can exist, the paradox itself continues to expand our understanding of what it means to know. The infinite monkey theorem. Can randomness create masterpieces? Imagine a monkey sitting at a typewriter, hitting keys at random. The monkey knows nothing of language, structure, or meaning. It simply strikes keys arbitrarily, producing a seemingly endless stream of letters. Now imagine that this monkey keeps typing, not for hours or days, but forever. Given infinite time, the monkey is bound to produce not only a few coherent words, but entire volumes of classic literature. It's a strange, almost absurd image, but it's the basis of the infinite monkey theorem. Given enough time, randomness can generate order, meaning, and even masterpieces. At first glance, the idea feels counterintuitive. How could pure chance produce something as intricate and deliberate as Shakespeare's Hamlet? Yet, mathematically, the theorem is sound. With infinite time and infinite keystrokes, every possible sequence of letters will eventually appear. That includes not only Hamlet, but every other play, poem, and novel ever written or ever conceivable. The infinite monkey theorem forces us to rethink the relationship between chance and order. In everyday life, we associate randomness with chaos. A random shuffle of cards scatters them into no discernible pattern. A random noise in a signal distorts the message. But on an infinite timeline, randomness becomes a canvas on which every conceivable pattern is painted. Even the most improbable arrangements, like a perfectly written Hamlet, become inevitable. Of course, the theorem isn't about real monkeys or typewriters. It's a thought experiment, a metaphor for understanding probability and infinity. In reality, no physical monkey could type forever, and no typewriter could endure infinite keystrokes. Instead, The theorem highlights a key property of infinite sequences. No matter how unlikely an outcome, given infinite chances, it must occur. This concept resonates far beyond the realm of hypothetical typing monkeys. It appears in fields as diverse as cryptography, genetics, and artificial intelligence. It challenges us to think about the interplay of randomness and structure in the natural world. In genetics, for instance, random mutations over billions of years have given rise to the complex order of life. In cryptography, vast numbers of random combinations form the basis of secure encryption. The infinite monkey theorem reminds us that randomness and order aren't always opposites. Sometimes they're part of the same continuum. The theorem also raises philosophical questions about creativity, meaning, and human uniqueness. If a random process given infinite time can replicate any masterpiece, what does that say about the nature of creativity? Does it diminish the value of human ingenuity? Or does it highlight how extraordinary it is that we achieve such feats in finite time? The infinite monkey theorem doesn't answer these questions, but it invites us to explore them, to wonder about the boundaries between chance and intention. In the end, the infinite monkey theorem isn't just a quirky mathematical curiosity. It's a lens through which we can view the infinite potential hidden within randomness. It challenges our assumptions about chaos, order, and the passage of time, and it leaves us with a profound realization. Even the most improbable outcomes become certain when infinity is at play. The puzzle of the unstoppable force and immovable object. Imagine a scenario where an unstoppable force hurtles toward an immovable object. The force cannot be slowed, stopped, or diverted, and the object cannot be moved, shifted, or destroyed. As these two meet, an inevitable question arises. What happens next? This puzzle, often phrased as a classic paradox, challenges our understanding of strength, resistance, and the nature of opposing extremes. At first, it seems that something must give. How can an unstoppable force continue its trajectory if an object remains perfectly fixed in place? Likewise, how can an immovable object retain its position when an unstoppable force pushes against it? The contradiction appears inescapable. The two concepts, unstoppable force and immovable object, cannot logically coexist in the same scenario. One way to approach this paradox is to consider the definitions themselves. By definition, an unstoppable force is something that cannot be halted. By definition, an immovable object is something that cannot be moved. If these definitions hold true, then the paradox is unsolvable, because it places two absolute and mutually exclusive conditions in direct conflict. In other words, if one exists, the other cannot. The paradox forces us to confront the limitations of our logic and language. Perhaps the very idea of an unstoppable force meeting an immovable object is inherently flawed, a conceptual trick that exposes the boundaries of our reasoning. Another perspective is to question whether the concepts themselves are absolute. In reality, no force is truly unstoppable, and no object is truly immovable. Even the strongest materials can break under sufficient stress, and even the fastest moving particles can be influenced by other forces. By viewing the paradox as a thought experiment rather than a literal scenario, we can use it to explore deeper ideas about the nature of physical laws, the limits of power, and the interplay of opposing forces. The puzzle also invites philosophical reflection. It can be seen as a metaphor for life's unresolvable conflicts, situations where two principles or goals collide with no clear resolution. In such cases, the paradox teaches us not to seek a definitive answer, but to explore the assumptions underlying the conflict. It challenges us to think about how we define absolutes, how we handle contradictions, and whether some questions are meant not to be answered, but to be pondered. In the end, the puzzle of the unstoppable force and immovable object isn't just about physics or strength. It's a thought experiment that stretches the mind, forces us to re-examine our assumptions, and reminds us that some questions defy resolution. The value of the paradox lies not in finding an answer, but in embracing the complexity and ambiguity that it represents. The Monty Hall problem. Do you switch doors? You're a contestant on a game show. Before you are three doors, and behind one of them is a grand prize, a shiny new car. Behind the other two doors are goats. You make your choice. Let's say door one. The host, who knows what's behind each door, then opens one of the other doors, let's say door three, and reveals a goat. Now the host gives you a choice. Stick with door one or switch to door two. What should you do? At first, it might seem like it doesn't matter. With two doors remaining, you might think the odds are 50-50, but that's not the case. The Monty Hall problem, named after the host of the game show Let's Make a Deal, is a famous probability puzzle that defies intuition. The counterintuitive truth is that you should always switch doors, because doing so gives you a 2-3 chance of winning, while sticking with your original choice gives you only a 1/3 chance. Why is this? The key lies in how the probabilities shift after the host opens a door. When you first choose a door, there's a 1/3 chance you've picked the car and a 2-3 chance you've picked a goat. When the host reveals a goat behind another door, that initial probability doesn't suddenly change. It just refines the situation. If you had a 2-3 chance of being wrong at the start, and the host's action always leaves one goat and one car, switching doors now takes advantage of that initial 2-3 probability. To make this clearer, consider multiple rounds. Imagine playing the game 100 times. If you always stick with your first choice, you'll win roughly 1/3 of the time because you're betting that you guessed correctly on the first try. But if you switch every time, you're essentially betting that you were wrong at the start, which happens 2/3 of the time, and you'll win about 66 out of 100 games. The more you play, the more this pattern reveals itself. The Monty Hall problem challenges our intuition because it asks us to think differently about probability. Our instincts tell us that once a door is opened, the remaining doors must have equal chances. But the reality is that the host's knowledge and actions, deliberately revealing a goat, change the situation. It's a lesson in understanding conditional probability, where the initial odds aren't erased by new information. Rather, that information helps refine the choices. This puzzle isn't just about winning cars or avoiding goats. It's a powerful example of how our instincts can mislead us, and how careful reasoning and probability theory can lead to counterintuitive insights. It shows us the importance of looking beyond gut reactions, of digging deeper into how events are connected, and of questioning what we assume to be true. In the end, the Monty Hall problem isn't just a game show riddle. It's a reminder that the world often works in ways that defy our expectations. By learning to think probabilistically, we can make better decisions, not just on game shows, but in life's many uncertain scenarios. The paradox of the ravine. When does a stream become a river? Imagine you're standing at the edge of a small, trickling stream. You can easily hop across it, the water barely covering your ankles. As you follow its course downstream, it grows wider and deeper, its current stronger. Eventually, the stream becomes so vast that you must cross it by bridge, its waters now coursing mightily through a broad, open valley. Somewhere along the way, the stream became a river. But at what exact point did this transformation occur? This is the paradox of the ravine. It's a version of the philosophical Sorites paradox, often posed with grains of sand and heaps. If you keep adding grains one by one, when does a collection of grains become a heap? With the ravine, the question is, at what point does a stream stop being just a stream and officially become a river? There's no single moment that stands out, no abrupt change, no visible marker. Yet clearly there's a difference between the small trickle at the source and the powerful river that forms downstream. The paradox forces us to confront the fuzziness of boundaries. It shows that many categories we take for granted are not as clear-cut as we'd like to believe. We tend to think of rivers and streams as distinct, but in nature, the transition from one to the other is gradual, continuous, and fluid. The same is true of countless other things. The point at which day becomes night, the line between youth and old age, the boundary between one stage of life and the next. The paradox of the ravine reveals that many of our definitions are not rooted in sharp, definitive changes, but in gradual transformations that defy simple categorization. In trying to resolve the paradox, some might propose setting arbitrary thresholds. For example, declaring that a waterway becomes a river when it reaches a certain width or discharge rate. But such thresholds are ultimately human constructs. Nature itself doesn't abide by these neat divisions. Instead, the paradox invites us to accept that many things exist on a spectrum. Instead of demanding clear lines, we can learn to appreciate the continuum and the beauty of gradual change. The paradox of the ravine also encourages us to think more deeply about how we label and classify the world. In a sense, it's not just about streams and rivers, it's about how we navigate a world full of ambiguity. By exploring this paradox, we're reminded that categories are tools we create to understand the world, not intrinsic features of reality. And sometimes, the most profound insights come from recognizing the fluidity and complexity of the boundaries we once thought were fixed. Ultimately, the paradox of the ravine isn't a puzzle that needs solving. It's a reflection of life's continuous nature, an invitation to embrace the in-between, and a reminder that the world is often richer and more complex than our definitions allow. The infinite stack of books. Which book is on top? Picture a stack of books stretching infinitely into the sky. Each book is placed perfectly atop another, their spines forming a straight vertical column. With no end to the stack, one might naturally wonder, which book is on top? Is it even possible to pinpoint a final book? Or does the infinite nature of the stack make that question meaningless? The infinite stack of books is a thought experiment that draws us into the strange and counterintuitive world of infinity. In our everyday experience, stacks have beginnings and ends, a top book, a bottom book. But when a stack is infinite, it no longer adheres to these familiar rules. If there's no highest book, no book that caps the column, then the very idea of a top loses its meaning. The stack just continues endlessly upward. This concept echoes the Hilbert Hotel paradox, where infinity defies our typical understanding of full or complete. Similarly, in the infinite stack of books, we see how the ordinary notion of a last or top item falls apart in the face of infinite extension. There's no final book you can point to, just as there's no final number in the infinite sequence of integers. Instead, the stack simply is an unending collection that challenges our finite intuitions. But the thought experiment also invites deeper reflection. What does it mean to describe something infinite? How do we conceptualize something that has no ultimate boundary or terminus? In everyday life, we rely on clear endpoints to define relationships, beginnings and endings, tops and bottoms. The infinite stack of books pushes us to think beyond those boundaries, to imagine a reality where end is not a relevant term. Mathematicians often deal with these concepts when discussing infinite sets or sequences. Just as the natural numbers have no largest number, an infinite stack of books has no single, identifiable top book. Yet, this doesn't mean the stack is meaningless. It still exists as a collection, even if we can't point to its final element. The infinite stack of books reminds us that infinity is not a number or a place. It's a concept that expands our understanding of existence and order. Ultimately, the thought experiment isn't about books or stacks at all. It's about how we grapple with infinity, how we stretch our minds to accommodate ideas that go beyond the finite world we know. In contemplating the infinite stack of books, we're reminded that some questions, like which book is on top, are not about finding an answer, but about exploring the boundaries of what we can comprehend. The circular argument. Does the conclusion ever end? Imagine you're presented with an argument that, instead of moving forward to a clear conclusion, loops back on itself. A is true because B is true, it states. But when you ask why B is true, the answer is because of A. Instead of leading to a definitive resolution, the reasoning forms a circle, with each claim depending on the other for validation. This is the essence of the circular argument, a logical paradox that can be both frustrating and enlightening. At first glance, the circular argument might seem absurd, an exercise in futility. How can you prove something by referring back to itself? Yet these loops can be surprisingly difficult to spot because they often masquerade as coherent logic. In everyday life, we frequently encounter ideas that feel sound until we examine them closely. Consider, for example, someone saying, "I know I'm trustworthy because I always tell the truth." If you ask, "How do we know you always tell the truth?" And the answer is, "Because I'm trustworthy," you've stepped into a circular argument. The paradox of the circular argument lies in its self-referential nature. Instead of grounding itself in an independent, external premise, it turns inward. This creates an illusion of reasoning that never actually progresses. It's a logical loop that can leave you endlessly chasing the answer without ever finding it. Yet, despite their logical flaws, circular arguments hold a certain allure. They reveal the ways we often take assumptions for granted. We might believe something to be true because it feels right or makes sense without realizing that our justification is just a reflection of our initial belief. By exploring circular arguments, we gain insight into the foundations of our reasoning and learn to recognize when we're building our conclusions on shaky ground. Philosophers and logicians have long studied circular reasoning as a tool for sharpening critical thinking. The ability to spot these loops can help you avoid logical pitfalls, strengthen your arguments, and approach problems with a more discerning mind. In this sense, the circular argument isn't just a paradox. It's a lesson in the importance of solid foundations and clear evidence. The paradox also raises intriguing philosophical questions. Is it ever possible to break out of certain circular patterns of thought? Are some beliefs inevitably self-referential? And if so, how do we distinguish between valid reasoning and circular justification? The circular argument challenges us to reflect on the very nature of knowledge and the ways we build our understanding of the world. In the end, the circular argument may not lead to a satisfying conclusion, but that's the point. It's not about finding an answer, but about recognizing the limits of certain types of reasoning. It reminds us that not all paths lead forward, and that some loops, no matter how tightly constructed, can never truly escape themselves. The twins paradox. Can two travelers age differently? Picture a pair of twins. One stays on Earth while the other embarks on a high-speed journey into space, traveling near the speed of light. After what seems like a short time for the traveling twin, they return to Earth only to discover that their sibling has aged significantly more. This is the twins paradox, one of the most famous thought experiments in physics. At its heart lies a fascinating question. How can two individuals who started out the same age end up experiencing time so differently? At first glance, this seems impossible. After all, aren't both twins subject to the same laws of physics? Shouldn't time pass at the same rate for everyone? Yet, Einstein's theory of special relativity tells us otherwise. Time is not absolute. It's relative to the observer's motion. The twin who traveled through space at near light speed experienced time differently, more slowly than the twin who remained on Earth. The faster you move through space, the slower time flows for you compared to someone who is stationary. This time dilation effect has been confirmed by experiments. High-speed particles in accelerators live longer than they would if they were at rest. Even astronauts aboard the International Space Station, moving at a much slower speed than light, but still faster than people on Earth, experience time just a tiny bit more slowly. The twins paradox magnifies this difference to a dramatic scale, illustrating how relativistic speeds can make time pass at vastly different rates for two observers. But the paradox isn't just a scientific curiosity. It challenges our intuitive understanding of time itself. We grow up thinking that time is a constant, a ticking clock that moves steadily forward for everyone. The twins paradox forces us to rethink this notion, showing that time is flexible, dynamic, and intimately connected to motion. It also prompts philosophical reflection. If time is relative, then so is our experience of life's passage. The twin who travels returns to find a world they barely recognize. People older, places changed, a lifetime compressed into what felt like a short journey. This raises questions about the nature of aging, memory, and continuity. What does it mean to live a long life if time itself is not constant? The twins paradox also inspires wonder about the future of space travel. As we dream of interstellar journeys, we must grapple with the idea that the travelers we send out may return to a world that has moved far ahead of them in time. It's a poignant reminder that our exploration of the universe isn't just about distance, it's about time as well. Ultimately, the twins paradox is not just a puzzle about two siblings. It's a window into the deep structure of the universe, a way of understanding how motion, speed, and time intertwine. It challenges us to expand our perspective, to think beyond the familiar, and to appreciate the strange and beautiful nature of time itself. The memory puzzle. Can you forget something you don't remember? Think back to your earliest memory. Perhaps it's a faint image of a toy, a glimpse of a smiling face, or the sound of a familiar voice. But now consider this. What about all the experiences that came before that moment? What happened in the days, months, or even years leading up to that memory? Why can't you recall them? And here's the real puzzle. If you can't remember those events, can you even say you've forgotten them? This is the paradox of memory and forgetting. How can you forget something you never truly remembered in the first place? It's a question that challenges our understanding of memory and the mind. If a memory is never formed, or if it fades before we consciously recognize it, does it still exist somewhere in the recesses of our brain? Or is it as though it never happened at all? Science offers some insights. Early in life, the brain undergoes rapid development, but it also experiences what's known as infantile amnesia. Most people can't remember events that occurred before the age of 3 or 4. Theories abound as to why this happens. Some suggest that the parts of the brain responsible for forming long-term memories, like the hippocampus, are not fully developed. Others argue that the way we encode and retrieve memories changes as we grow, making those early experiences inaccessible in later years. But even outside of infancy, the memory puzzle persists. We forget details of conversations, faces of people we once knew, or facts we learned in school. Sometimes we're aware that we've forgotten something, like struggling to recall a name or a piece of trivia. But other times, we have no idea what we've lost. If you don't know that you've forgotten a particular event, can you really say you've forgotten it at all? Or does it simply disappear into the void, as though it never existed? This paradox invites philosophical reflection. It raises questions about the nature of existence and experience. If an event or a fact no longer resides in your conscious awareness, what is its status? Did it ever truly exist for you if you can no longer recall it? Is forgetting an active process, or is it more like a shadow, something that lingers only until the light of attention moves elsewhere? The memory puzzle also challenges us to think about identity. Our memories shape who we are, but if so much of our experience is lost to forgetting, what does that mean for the self? Are we defined only by what we remember, or do our forgotten experiences leave an imprint we cannot see? The paradox encourages us to view memory not just as a personal archive, but as a dynamic, shifting aspect of our being, something that is constantly in flux, blending what we recall with what we can no longer grasp. Ultimately, the question of whether you can forget what you don't remember is less about finding a definitive answer and more about exploring the nature of memory, awareness, and the mind. It's a reminder that our understanding of memory is still evolving, and that the mysteries of forgetting are as profound as the mysteries of remembering. The puzzle of the perfect circle. Does it exist in reality? Picture a perfect circle, flawlessly round, its curve unbroken and uniform, a seamless form without any irregularity. You can imagine it in your mind, draw a close approximation on paper, or even generate one with precise mathematical equations. But here's the question. Can a truly perfect circle exist in the physical world, or is perfection something that remains forever out of reach? At first, the idea of a perfect circle seems straightforward. Mathematics defines it precisely. All points are equidistant from a central point, forming a continuous, smooth curve. Yet the physical world introduces imperfection. When you draw a circle with a compass, you're limited by the precision of your tools, the texture of the paper, and the steadiness of your hand. No matter how careful you are, the circle you create will have tiny flaws, slight variations in curvature, microscopic bumps, or inconsistencies in line thickness. Even advanced technology doesn't solve the puzzle. A computer can render a near-perfect circle on a screen, but that image is made up of pixels, tiny squares that approximate the curve. The closer you look, the less perfect it becomes. Similarly, if you try to machine a perfect circular object, the limitations of materials and measurement tools prevent true perfection. On an atomic level, the surface will have irregularities, no matter how finely polished it appears to the naked eye. The puzzle of the perfect circle isn't just about geometry, it's about the gap between ideal forms and physical reality. In mathematics, the perfect circle exists as a concept, a pure abstraction that can be defined, analyzed, and manipulated with absolute precision. But in the tangible world, we only have approximations. This raises philosophical questions. Is perfection a useful goal, or is it simply a guiding principle, something we strive for, but never fully achieve? Does the pursuit of perfection help us understand the world, or does it distract us from appreciating the beauty of what's actually possible? Beyond geometry, the puzzle of the perfect circle mirrors other challenges in human experience. We often hold ourselves or our creations to impossible standards, seeking flawless results in art, design, or personal achievement. The realization that perfection may be unattainable doesn't diminish the value of the pursuit. Instead, it highlights the importance of striving for excellence, knowing that the journey itself, the effort, the refinement, the attention to detail, is where meaning is found. Ultimately, the perfect circle reminds us that some ideas belong to the realm of thought rather than the physical world. It challenges us to embrace imperfection, to recognize that the ideal and the real are not always the same, and to find beauty in the nearly perfect forms we create. In the end, the perfect circle may not exist in reality, but it continues to inspire us to imagine, to innovate, and to dream. The paradox of the silent room. When is silence truly silent? Imagine stepping into an anechoic chamber, one of the quietest places on earth. The walls, floor, and ceiling are lined with special materials that absorb sound waves, eliminating echoes. Inside, there's no hum of machinery, no rustle of wind, no faint murmur of distant traffic. At first, it feels like a profound silence. But then, as you listen closer, you begin to hear the sound of your own heartbeat, the rush of blood in your ears, and even the faint creaks of your joints as you move. The silence is not as silent as you expected. This raises an intriguing question. Is true silence ever possible, or is it just an illusion? This is the paradox of the silent room. The quieter the environment, the more your own body's sounds rise to the surface. In a completely soundproof space, the external noise is gone, but the internal noise remains. This highlights a fundamental tension. Silence, as we imagine it, may never truly exist. Even in the most acoustically controlled environment, we carry our own soundtrack, one we can't escape. The paradox challenges our understanding of silence itself. Is silence merely the absence of external noise, or does it mean the total absence of sound? If it's the latter, then no place can ever be truly silent as long as you're present. Your body becomes the last source of noise, a reminder that silence is always relative. This thought experiment invites us to reflect on the nature of perception. What we think of as silence often depends on contrast. In a bustling city, a quiet park can feel silent. In a quiet park, an anechoic chamber might seem like absolute stillness. But as the external noise diminishes, our awareness shifts inward. We hear what we couldn't hear before, and we realize that silence is not an objective state, but a subjective experience. The paradox of the silent room also raises philosophical questions about our relationship to noise and sound. Why do we seek silence in the first place? Is it because we want to escape the world's chaos? Or because we hope to find clarity in stillness? And what happens when that stillness turns out to be filled with sounds we never noticed? The paradox suggests that silence is not just about the absence of noise. It's about how we perceive and interact with the sounds around us and within us. In the end, the paradox of the silent room reminds us that silence, like many ideals, may be unattainable in its purest form. But that doesn't mean the pursuit of silence is futile. Instead, it encourages us to redefine what we mean by silence and to appreciate the nuanced relationship between sound, perception, and the quiet spaces we seek. The paradox of the tortoise and Achilles. Who really wins the race? Imagine a race between the swift hero Achilles and a slow-moving tortoise. To give the tortoise a fair start, Achilles allows it to begin some distance ahead of him. As the race begins, Achilles quickly closes the gap. But by the time he reaches the point where the tortoise started, the tortoise has moved forward a little. When Achilles reaches that new point, the tortoise has advanced yet again. No matter how small the distance becomes, the tortoise always seems to remain ahead. This is the ancient paradox of Zeno, often called the tortoise and Achilles paradox. On the surface, it appears to defy common sense. Achilles is obviously faster and should overtake the tortoise. Yet the logic of the paradox suggests that he never will. Each time Achilles reaches the tortoise's previous position, the tortoise has moved a bit further. Even though these distances get smaller and smaller, there are always infinitely many points Achilles must reach. How can he ever catch up? The paradox forces us to grapple with the nature of infinity and continuous motion. It's not that Achilles can't overtake the tortoise in real life. He clearly can. The paradox lies in the way we think about dividing time and space into an infinite number of steps. If each step takes some finite amount of time, and there are infinitely many steps, it seems that Achilles would never finish closing the gap. Yet we know that in the real world, this isn't the case. Mathematicians and philosophers have used Zeno's paradox to explore the concept of limits and infinite series. By summing the infinite sequence of smaller and smaller times required to reach each new point, we find that the total time is finite. Modern calculus resolves the paradox by showing that an infinite number of diminishing steps can indeed add up to a finite distance. Achilles does catch the tortoise, and he does so in a calculable, finite amount of time. But beyond the mathematics, the paradox raises deeper philosophical questions about the nature of motion, time, and our understanding of reality. It asks us to consider how we divide and measure the continuous flow of the world. It highlights the tension between our intuitive sense of movement and the abstract way we think about infinite processes. The tortoise and Achilles paradox challenges us to think more carefully about how we define progress, change, and the steps in between. In the end, the paradox is not just a puzzle about a race, it's a window into the complexities of motion and infinity, a reminder that even the simplest scenarios can contain profound mysteries. By exploring these ideas, we not only come to understand the paradox itself, but also gain insight into the deeper principles that govern the way we move through space and time. The puzzle of the four-color map. Can every map be solved? Imagine a map of several regions, countries, states, or territories, where no two neighboring regions share the same color. How many colors are needed to accomplish this? At first, it might seem that an intricate map with complex borders could require 5 or 6 colors, or even more. Yet, the four-color theorem asserts that 4 colors are always enough, no matter how complex the map. This claim sounds almost magical. Could every conceivable map really be solved with just 4 colors? For centuries, mathematicians struggled with this question. The puzzle was first proposed in 1852, and though many believed it to be true, no one could prove it. Decades of failed attempts followed, with both brilliant minds and eager amateurs offering proofs, only to have them eventually refuted. The four-color puzzle became one of the most famous challenges in mathematics, a seemingly simple question that resisted resolution for over a century. Finally, in 1976, 2 mathematicians, Kenneth Appel and Wolfgang Haken, announced they had proved the theorem. Their approach, however, was highly unconventional. Instead of relying solely on pen and paper reasoning, they used a computer to help verify the proof. They broke the problem into thousands of cases and had the computer check each one. The result? Confirmation that 4 colors truly are enough for any map. It was a historic moment, but not without controversy. Some mathematicians felt uneasy about relying so heavily on a machine. Could a proof really be trusted if no human had verified every step by hand? The puzzle of the four-color map also raises deeper philosophical questions about the nature of mathematical truth. Is a proof valid if it depends on computational verification? What does this say about the relationship between human reasoning and artificial computation. While the mathematical result is now widely accepted, the method of its proof continues to provoke discussion about the role of technology in understanding mathematical reality. Beyond the technical challenges, the four-color map puzzle offers a broader lesson about simplicity and complexity. It's a reminder that even problems that seem straightforward can hide profound difficulties. The fact that every map can be colored with four hues shows how patterns and rules emerge from complexity. It's not just about maps. It's about the underlying order that exists in systems that appear chaotic. In this way, the puzzle resonates far beyond cartography, touching on themes of structure, logic, and the surprising simplicity that can be found in the heart of complexity. Ultimately, the puzzle of the four-color map isn't just about coloring regions. It's a testament to the enduring human quest to understand patterns, to solve problems that seem impossible, and to explore the limits of reason, whether with a pencil, a computer, or a leap of imagination. The riddle of the perfect crime. Is any plan truly foolproof? Imagine a flawless plan, meticulously thought out, leaving no evidence and no witnesses. Every detail is covered, every contingency accounted for. It's a perfect crime, one that seems impossible to unravel. But is such a thing truly possible, or is it a mere illusion, a riddle that vanishes the moment we look closer? This question has captivated writers, philosophers, and detectives for centuries. The idea of the perfect crime, a crime so carefully executed that it leaves no trace, invites us into a world of paradox and uncertainty. The riddle lies in the tension between the planning and the reality. Can any human plan ever be completely foolproof? Or is the very concept of perfection inherently flawed? At first glance, perfection in a crime seems attainable. With enough time, resources, and intelligence, it seems conceivable that someone could construct a scheme so tight that no one could ever prove wrongdoing. Yet history and experience tell us otherwise. Even the most brilliant criminal plots eventually unravel, often due to unforeseen human error, random chance, or a small overlooked detail. The so-called perfect crime, when examined under the lens of reality, starts to reveal cracks. The riddle deepens when we consider the role of technology and knowledge. In the past, a crime might have been considered perfect simply because the methods to detect it didn't exist. But as forensic science advances, so does our ability to uncover what was once undetectable. DNA analysis, digital surveillance, and data forensics have solved cases that once seemed unsolvable. What was perfect in one era may become glaringly imperfect in another. There's also the human factor. Emotions, guilt, and unforeseen interactions can derail the best laid plans. People slip up, they talk when they shouldn't, leave behind small traces they didn't notice, or encounter unpredictable events. The riddle of the perfect crime isn't just about the plan itself. It's about the unpredictable nature of human behavior. Even the most careful individual can make a mistake or be caught off guard by something they couldn't anticipate. Philosophically, the idea of perfection is always elusive. To call a crime perfect would mean it has no flaws, no possible way for it to be discovered or proven. But how do we measure something that hasn't been revealed? If a crime is never discovered, how do we know it was truly perfect and not just lucky? The riddle of the perfect crime challenges our understanding of certainty. It asks whether perfection is an achievable goal or just an idea, a standard that crumbles under closer scrutiny. Ultimately, the riddle isn't just about criminal plots. It's a reflection on the nature of planning, the limits of control, and the ways that life resists our attempts to create perfection. The pursuit of a perfect crime, like the pursuit of perfection in other areas, may be more about the journey, the intellectual challenge, than the actual outcome. The riddle of the perfect crime remains unsolved, not because it lacks answers, but because it forces us to confront the limits of our knowledge and the unpredictability of the world. The infinite garden, can it ever be fully explored? Imagine stepping into a garden that stretches out endlessly in all directions. At first, it seems like an ordinary, beautiful place, lush trees, colorful flowers, and winding paths. But as you walk, you begin to realize that no matter how far you go, the garden never ends. Every turn reveals more paths. Every clearing leads to new groves. No edge, no boundary, no end. The question arises, can you ever fully explore this infinite garden? This thought experiment places you in the middle of a paradox. How do you navigate something that has no limits? If the garden is truly infinite, then no matter how much ground you cover, there will always be more to see. Every step forward expands the horizon, and every attempt to map it out leaves countless areas unexplored. The act of exploration itself becomes an endless journey. The infinite garden serves as a metaphor for many aspects of human understanding. Consider knowledge or discovery. Just as you can't fully explore an infinite garden, you can never know everything there is to know. Each new insight, each breakthrough, opens the door to new questions, new mysteries, and new terrain to cover. The more we learn, the more we realize how much more there is to learn. The paradox of the infinite garden mirrors our pursuit of knowledge, a quest that can never truly be finished. This idea also resonates with our experience of creativity and imagination. The infinite garden can symbolize the boundless possibilities of human thought. Artists, writers, and inventors often speak of their work as a kind of journey through uncharted territory. Even when they complete a piece, there are always new ideas to explore, new projects to begin. The infinite garden reflects this inexhaustible well of inspiration, a reminder that creativity has no final destination. But the paradox also invites us to think about our relationship with the journey itself. If the garden can never be fully explored, should we still try? The answer lies in shifting our focus. Instead of striving to finish the garden, we can find meaning and fulfillment in the act of exploring it. Each step, each new discovery, each moment of beauty is valuable in its own right. The infinite garden becomes less about reaching an end and more about appreciating the process, the endless adventure of uncovering what lies around the next bend. In the end, the infinite garden isn't just a place, it's an idea, a way of thinking about the vastness of life's possibilities. It reminds us that some quests don't have endpoints, and that's what makes them worthwhile. The garden's endless paths and ever-expanding vistas reflect the boundless potential of the human spirit, encouraging us to keep exploring, keep learning, and keep imagining what might lie ahead. The paradox of the stone. Can an omnipotent being create a stone it cannot lift? Imagine an all-powerful being, capable of doing anything, no matter how extraordinary or impossible it may seem. Now ask yourself this: could this being create a stone so heavy that even it cannot lift it? At first, the question seems straightforward, but as you think more deeply, it becomes a paradox. If the being can create such a stone, then it must not be all-powerful, because it cannot lift the stone. But if it cannot create the stone, then it also fails the test of omnipotence. In either case, the concept of unlimited power appears to break down. This puzzle, often referred to as the paradox of the stone, challenges our understanding of omnipotence and logical consistency. It asks whether the very idea of absolute power can be coherent or if it inevitably leads to contradictions. In other words, is the concept of doing anything truly meaningful if it includes tasks that defy logic? One way to approach the paradox is to consider the nature of the tasks themselves. Some philosophers argue that omnipotence does not include the power to do things that are logically impossible. Creating a stone so heavy that an omnipotent being cannot lift it might be seen as a contradiction in terms, much like trying to draw a square circle. If you accept that omnipotence only covers what is logically possible, then the paradox dissolves. Such a stone cannot exist, and the being's power remains intact. Others, however, take a different view. They suggest that the paradox is a fundamental problem for any concept of absolute power. By defining omnipotence as the ability to do literally anything, you invite contradictions. This forces us to question whether omnipotence can ever be a coherent idea. If no being can perform logically contradictory actions, then perhaps true omnipotence is impossible by definition. The paradox becomes a way of highlighting the limits of our own definitions and assumptions. The paradox of the stone also raises philosophical questions about language and meaning. What does it mean to say something is too heavy to lift? If we define omnipotence as boundless ability, does it even make sense to speak of limits in that context? The paradox invites us to examine how we use words like power and ability, and whether our language can fully capture the idea of something infinite or absolute. Ultimately, the paradox of the stone is not just a theological or philosophical riddle. It's a thought experiment that forces us to confront the nature of power, possibility, and logic. It challenges us to think more deeply about what we mean when we say something is all-powerful, and whether some concepts are inherently self-defeating. In the end, the paradox doesn't provide a simple answer, but it does offer a profound lesson about the complexity of the ideas we often take for granted. The puzzle of the self-reflecting mirror. What lies beyond reflection? Imagine standing before a perfectly polished mirror. When you look into it, you see yourself, your movements, your expressions, your surroundings, flipped left to right, but otherwise completely accurate. The reflection seems simple. Light bounces off you, hits the mirror, and returns to your eyes. But now consider a different question. What happens when a mirror reflects not just you, but another mirror? When two mirrors face each other, creating an endless cascade of reflections within reflections, what exactly are you seeing? And what, if anything, lies beyond that infinite regression? This is the puzzle of the self-reflecting mirror, a thought experiment that explores the nature of perception, infinity, and the limits of what we can truly see. When two mirrors reflect each other, the image becomes a tunnel of repeating frames, each one slightly smaller and dimmer than the last. In theory, this sequence could go on forever. But in reality, imperfections in the mirrors, the quality of the light, and the limits of our own vision eventually cause the reflections to fade. The infinite depth we imagine is never fully realized. The puzzle doesn't end with physics or optics. It invites deeper philosophical questions. If each reflection is simply the previous one repeated, does the sequence have any real depth? Or is it just an illusion of infinity? And if you could somehow have perfect mirrors in perfect conditions, would the reflections truly go on forever? Or would something else, some underlying limit, eventually stop them? This idea also raises questions about the nature of observation. When you look at yourself in a mirror, you see a single, clear image. But as soon as that mirror reflects another, your gaze shifts. Are you still looking at yourself, or at an endless series of copies that slowly lose their resemblance? In a sense, the self-reflecting mirror becomes a metaphor for how we perceive ourselves and the world. What we see is never just one thing, but a chain of interpretations, each influenced by the ones before it. The puzzle of the self-reflecting mirror also touches on the concept of infinity in a tangible way. Unlike abstract numbers or theoretical constructs, the reflections are something you can see, something that feels real. Yet that reality is limited by the imperfections of the physical world. This tension between the infinite and the finite is what makes the puzzle so intriguing. It reminds us that even when we think we're glimpsing something endless, what we're really seeing is shaped by the constraints of our surroundings. Ultimately, the puzzle of the self-reflecting mirror isn't just about mirrors. It's about the way we understand reflection, both literal and metaphorical. It challenges us to think about the boundaries of perception, the nature of repetition, and the line between what is real and what is imagined. By standing before a self-reflecting mirror, we not only see an endless cascade of images, but also a reminder of the endless questions that arise when we look closely at the world around us. The riddle of the perfect game. Is there a strategy that always wins? Imagine you're sitting down to play a game, not just any game, but one where the rules are perfectly clear, the strategies can be fully mapped out, and no element of luck is involved. Perhaps it's a simple board game, a pure logic puzzle, or a classic match of tic-tac-toe. With perfect information and no hidden variables, the question arises, is there a perfect strategy, a single plan of action that guarantees you'll never lose? This is the riddle of the perfect game, a thought experiment that challenges our understanding of competition, logic, and the pursuit of an unbeatable strategy. It asks, if every move can be calculated and every counter move anticipated, can one player always ensure victory, or, at the very least, never lose? At first glance, the idea seems plausible. After all, certain games, like tic-tac-toe, are solved. This means that, with perfect play from both sides, the outcome is predetermined. In tic-tac-toe, for example, two players who follow optimal strategies will always end in a draw. Similarly, some versions of checkers have been partially solved, revealing paths to guaranteed draws or wins under specific conditions. Chess, while vastly more complex, is believed to have an optimal strategy that would emerge if enough computational power and time were available. But the riddle goes deeper than individual games. It forces us to consider the nature of decision-making itself. If a perfect strategy exists, does it mean the game loses its meaning as a contest? If one player always knows the winning moves, the other player can only ever hope to achieve a stalemate or inevitable loss. The thrill of competition, the uncertainty of the outcome, disappears. In a sense, the existence of a perfect strategy turns the game into a performance of predetermined steps rather than a dynamic struggle. The riddle also invites reflection on the limits of knowledge and computation. While certain games have been solved, many others remain far beyond our reach. The complexity of chess, Go, and other strategic games explodes exponentially as they progress, making it practically impossible, for now, to identify a perfect strategy. This gap between theory and practice raises the question, is a perfect strategy meaningful if it's so complex that no human or computer can realistically apply it? If the solution exists in theory but not in practice, does it truly count as perfect? Philosophically, the riddle of the perfect game touches on the balance between predictability and creativity. Games are often seen as microcosms of life, structured environments where we navigate challenges, make decisions, and adapt to unexpected moves. The notion of a perfect strategy challenges this idea, suggesting a world where every choice is preordained, every outcome inevitable. Yet, this deterministic view can feel at odds with the joy of discovery, the thrill of innovation, and the satisfaction of finding your own path through a problem. In the end, the riddle of the perfect game is not just a question about winning or losing. It's a lens through which we explore the nature of strategy, the value of competition, and the role of uncertainty in human experience. Whether or not a perfect strategy exists for every game, the riddle reminds us that the pursuit of mastery is often more fulfilling than the certainty of victory. The puzzle of the untold story. Is there a book that contains all stories? Imagine a single book, infinite in length, that contains every story ever told, every story that could be told, and even those that will never be told. Within its pages are the works of Shakespeare and Homer, the lost legends of ancient civilizations, and every novel yet to be written. If such a book existed, would it be possible to read it? Would it be meaningful? And, most puzzling of all, would it even truly be a book? This is the puzzle of the untold story, the idea that every possible narrative might be contained in a single, infinitely long text. At first glance, the concept seems tantalizing. With every plot, character, and setting represented, the book would hold the entirety of human imagination and beyond. But when we look closer, contradictions and questions arise. If the book truly contains all possible stories, then it must also include every variation of those stories. For example, one version of Hamlet might end as we know it, while another could have Hamlet survive and become king, or even set out on a journey to Mars. The book would include every possible deviation, from the profound to the absurd. In doing so, it might become incomprehensible, a chaotic sea of words that no reader could fully navigate. The puzzle also touches on the relationship between finite human experience and the infinite possibilities of narrative. Even if such a book existed, no one could ever read it in its entirety. We'd only encounter fragments, glimpses of the infinite whole. This raises questions about the nature of meaning. Can a story truly exist if no one reads it, if no one interprets it or connects it to their own experience? The untold story is, by definition, never known. Does it have value, or is its very existence a paradox? Philosophically, the puzzle reflects on the limits of knowledge and imagination. If we could somehow access all stories, would storytelling lose its magic? Part of the power of a story lies in its uniqueness, its ability to surprise and engage us. An infinite book, containing every possible twist and turn, might render individual narratives meaningless. Every ending would be predictable, every character's fate already written in another part of the text. The process of discovery, of crafting a story, of choosing words carefully, of unfolding events, might vanish in the face of infinite repetition. The puzzle of the untold story also invites us to consider the purpose of stories themselves. Are they meant to reflect reality, to inspire, to teach, or to entertain? If every possible story is already written in this hypothetical book, then what role does the storyteller play? The puzzle suggests that the act of telling, of choosing which story to share and how to share it, is just as important as the story itself. The infinite book might contain all stories, but without a storyteller, it's just an endless, unread text. Ultimately, the puzzle of the untold story isn't about finding a literal infinite book. It's about exploring the tension between the finite and the infinite, the known and the unknown. It challenges us to think about what gives stories their meaning, what makes them matter, and why we tell them at all. The book that contains every story may be an impossible dream, but the puzzle it poses continues to inspire reflection on the nature of imagination, creativity, and human experience.